We're going to talk about half-angle formulas here, and the last, when I looked at my notes, I think I got all but one short example I was going to do covered, so it'll be fine if I don't get that one done. It doesn't need its own video, and I think if I can be very efficient in my words and my explanations, that I can get this done in one video as well. I apologize that some of those were getting a lot longer than what I meant. So we have started with sine x and said, well, I know what to do if I have sine 2x. I can write it in terms of sine of x. And I know what to do if I have sine squared x. I can write it in terms of cosine 2x. But what if I have sine or cosine of half of x? Or most often it'll be written as x over 2. Now this was one on the page in the video we just finished. There in the middle, it's in the box. And this is one I said we'll use this later. If I want to find the sine of x over 2, I can solve this equation for that by taking the square root of both sides. Now, don't forget from college algebra that if I am the person that puts the square root into the problem myself, it was not there when I started, but I put it in. I have to put a plus or minus there to take into account all of my possibilities. When you look on the formula card, on that inside flap of your textbook, it probably writes it like this, all over 2 instead of with the 1/2. But it does have the plus or minus out in front. What I have to be careful and be aware of is that plus sign or that minus sign, well, it depends on what quadrant I'm in. And hopefully I know enough about the situation that I can determine that along the way. If I want to find the cosine of x over 2, I could have done an equivalent thing to what I did up above there, like we did with sine squared. But it is going to be plus or minus the square root of 1 plus cosine x, all divided by 2. If I'm after tangent of half an angle, then it is either 1 minus cosine x, your book has u's instead of x's, but I've already started with this, over sine x. Okay. Or, if it's more helpful to me, I can write it as sine x over 1 plus cosine x. Okay. If you want a fun exercise, try to make one of those look like the other. And I can tell you, I'll whisper the word conjugate, because that's what you would need. Okay. So let's say that from this, maybe I can shrink it all down and stay on the same page for right now. I'm kind of small up here, but where I can still see them. And maybe I am told that the cosine of u is equal to 7 over 25. I'm also told that u is in quadrant 1. Knowing that u is in quadrant 1, that means it's between 0 degrees and 90 degrees. If I cut that number in half, I'm going to get a number between 0 degrees and 45 degrees, meaning I'm still in quadrant 1. So that's helpful for me to know. When I draw my picture in quadrant 1, I have 7 for my opposite side and 25 for my adjacent side. And so that means if I do Pythagorean theorem, I will find out that I get 24 for my opposite side. From our diagram here, we can find a number of things. If I said, let's find sine u, we can do that by taking the opposite side over the hypotenuse. Maybe I said, I really want to know what sine 2u is from one of the last videos. You say, well, that's 2 times sine u times cosine u. So we would have 2 times sine u times cosine u. And the bottom is 625, and I think I wrote down the top. Here would be 336. Okay, that doesn't reduce because 7 and 24 and 2 don't have any common factors with 625. If I want to find sine of u over 2, sine of u over 2, then that is going to be, I'm going to leave my plus or minus written there for right now, 1 minus cosine u all over 2. Now, if, as I said before, if u is in the first quadrant, then half of u is also going to be in the first quadrant. I know everything in the first quadrant is positive. Okay? If your answer is a positive number, you do not have to put the plus sign out in front of it. But I'm going to put it there to indicate that I thought about it and I understand that positive is the right answer. So 1 minus cosine of u all over 2. 25 minus 7 is 18 over 25. And half of that, is 18 over 50. And if we reduce that to lowest terms, we get 9 over 25 under the radical. So sine of u over 2 is going to be equal to 3/5. Again, knowing what quadrant I'm in, knowing one piece of information about an angle. Here it was that cosine u was 7/25. I can find a number of things now. And again, notice that sine of u is 24 over 25, and sine of 2u is not just double that. A lot of students are like, well, I'll just take it times 2. It's not. It's 336 over 625. Okay, sine of half of u, also not half of 24/25. It was 3 over 5, and they're not always nice numbers like that. Sometimes they're ugly fractions. Next example, back to solving equations. Let's say we have sine of x over 2 plus cosine x minus 1, equals 0. If I look, I have x over 2's, I have x to the first, and I can't, if I change my sine x over 2 into cosine x's, it's stuck under a radical, and I really would rather not go there. Ooh, I might try that later and see how nasty it is. I think you could get there, but it wouldn't be any fun. Okay, so our goal is to, it'd be nice to stick only with sines, if I could. It'd be nice to keep my x over 2 there, and write cosine in terms of that. So if I look at cosine x as being 2 times x over 2, I could use my, this might take a little bit for some of you to see. Okay, I could think of this as cosine of 2u, and I can rewrite the cosine of 2u, I can rewrite it as 1 minus 2 sine squared u. If cosine x is cosine 2u, I can write cosine 2u as 1 minus 2 sine squared u, okay, where u is half of x. If we start looking here at things we can simplify, my 1's are now gone. I'm going to write the squared term first, just so my eyes can see it better. And I know, again, my favorite way to solve an equation, if I can do it, is to factor. So here in a moment, I want you to pause the video, try to factor this, try to find the solutions. Let's find all of them, because this one's a little bit different. And then come back to me when you're ready to see this worked out. All right, so since those ones went away, I actually liked it better in the order it was written the first time. But here are the two equations we want to solve. So here's a little checkpoint. You can try to get to here if you weren't, and then pause it again, and we'll write solutions next. Next checkpoint here, we haven't solved for x yet, but x over 2, sine is 0 at 0 and pi. Sine is 1/2 at pi over 6, and second quadrant 5 pi over 6. And I'll pause it again if you need to before you solve for x. Multiplying everything through by 2, I just get a 4n pi, and here, again above my other blue box, if you factor out the 2 pi, then you have 2n plus 1, you have an odd number times 2 pi. I would have to think if you could make that look any nicer. On the right in the box, pi over 3 and 5 pi over 3 plus 4 n pi's. We're not adding 2, 4, 6, 8, 10 pi, we're adding 4, 8, 12, 16, 20 pi, and taking that away and skipping over the other ones. Okay, so give me a shout if you need something.